Alright, so let's get started on FRQ number 4. And so this takes the concept from the last problem and builds off of it and uses it to solve a problem. And so this question asks, a cart of mass 5.3 kilograms initially moves at 5 meters per second and is subject to an impulse which can be found from the graph. What is the final speed of the car if the force acts in the direction of the initial velocity? Alright, so the first thing we're going to want to do is let's go ahead and might get a diagram going. So I'm not going to do any of my beautiful pictures from the last video. I'm just going to do a box. And so you have a cart. It's 5.3 kilograms. And it's moving along at 5 meters per second. And then you put an impulse on it. You put a force over time, and then that is what this graph tells us. Alright, so first, let's do this. Let's find out what the impulse is. Let's not drive in a circle. Alright, so, like before, since we have a force over time graph, you can simply treat this as a triangle, and the area under the triangle will be the impulse. So, again, 1/2, and the base here is 8. And the height is also 8. So you do 8 times 8, which is 64, divided by 2, go 32. So the impulse is 32 newtons per meter. Alright, and so let's go ahead and write down the formulas we're going to need. If you remember question 2, it's going to be the same set of formulas that we used for that. So the change in momentum is equal to mass times velocity. And the reason why it's not change in mass times change in velocity is because the mass is going to stay the same. The momentum is going to change, so therefore the only other thing that could change on the right side of the equation is the velocity. So that's the equation for that. Then there's change in P is equal to, or change in momentum is equal to the impulse, and that's just a definition. And then we have we have J is equal to F times D. Alright, so with that, we can start solving this. All we really need to know is that 32, okay, which is our impulse that we found out over here, is equal to 5.3, and that is our mass, times a change in velocity. And so that would be 5 plus whatever. And so if you're a little confused on where I got this from, so we've set all this out. We said change in P is equal to M times change in V, and then change in P is equal to J, right? So what I did basically is, because these two are equal to each other, I said J is equal to M times change in V. And so J, which is an impulse, we found out over here, and then M was given to us. And then change in velocity, I just put some arbitrary value. It doesn't matter what we really put here, but this is going to be our final velocity, whatever happens in this term, be final. So let's go ahead and divide by 5.3, and you get 6.038 is equal to, let's just say, V final. You really don't need this term. Unless you want to find out how much it changed by, then you can use this. Because you could subtract 5 from both sides. You could say x equals 1.038. It increased by 1.038. But you don't need to know that. You just need to know the final velocity. So you can just scratch this out. You can use this as a variable of itself. And so you can say the final velocity is 6.038 meters per second. And that would be your, step number 4. And this makes sense because if you apply an impulse to it, you're applying a force over time. And so if you apply a force over time, it's going to move faster than it did before. And so since our answer is greater than what the initial velocity was, this answer does indeed make sense.